Hello everyone, how to solve this problem for the values of a if we have log of a with base 2 plus log of a with base 3 is equals to 5, and we solve this problem for all the values of a, and at the last we will be verify that is this value of a be the solution or extraneous root. So I hope so you like this method, and now we move toward the solution of this problem. So here first we use this nice property of log, and you know about that if we have log of base a and b, so we write this term as log of b divided by log of a. So according to this property of log, here we apply this property of log on both of these two terms, and after applying this property our above equation is written as in this form. So first you have log of a divided by log of 2, and plus from here we have log of a divided by log of 3 is equals to 5. And now you see here log of a be the common term, so that we will take common log of a from here, and after taking common log of a we get the remaining values are 1 over log of 2 plus this is 1 divided by log of 3 is equals to 5. And further in the next step we need to take the LCM of this term, and when we take the LCM it will be written as log of a into here when we take the LCM it will be written as log of 2 multiplied by log of 3. So this is the LCM of this term, and when we divide this log of 2 on these two terms, so log 2 and this log 2 are cancelled out by each other, and we get here log 3, and log 3 multiplied by 1 becomes here log 3 plus, and this log 3 is cancelled out by this log 3, and we will get here log 2, and this whole equation is equals to 5. So here we need to focus on this expression, and here we apply the nice property of log. You know about that if we have log of a multiplied by b, it is equals to log of a plus log of b. So according to this property of log, here we just combine these two logs according to this property. So we write this term as log of a into this will be written as log of 3 multiplied by log of 2. So it will becomes here log of 3 times of 2, and it is divided by log of 2 multiplied by log of 3, and this whole equation is equals to 0. And in the next step here we just write this log 2 on this term, and it will be written as log of a divided by log of 2 into this is 2 times 3 becomes 6. It will be written as log of 6 divided by log of 3. So here these two terms are multiplied by each other, so we write this term in the denominator of this, and this term in the denominator of this, and this whole equation is equals to 5. So here we again apply this property of log. So according to this property, we again write here both of these two terms as in this form. So when we combine these two logs, it will be written as log of base 2 with a is multiplied by, we write this term as this is log of 6 with base 3 is equals to 5. So here you see that this log 6 with base 3 is multiplied by left hand side. So when we move it into the right hand side, it is divided by 5, and it will be written as log of base 2 with a is equals to, this is 5 multiplied by 1 divided by log of base 3 and 6. Okay, so when we move here this term to the right hand side, it is divided by here. So further in the next step here we need to use the definition of logarithm, and you know about that if we have a log of a to the power of x is equals to b. So this we know that by the definition of log, this term is implies, if and only if implies that here we need to move this x in the place of b, and we move b in the place of x, and we just remove this logarithm sign, and it will be written as a to the power of b is equals to x. So basically this is the definition of logarithm, common logarithm. So now we use this definition on here, and we move this a to the right hand side, and we move all the terms from right hand side to the exponent of these two. So after applying this definition of log, we write here our above equation as in this form. So first we move all of these terms in the exponent of 2, and it will becomes here 2 to the power of 5 divided by log of base 3 and 6 is equals to, we move a to the in the right hand side, and we get here equals to a. Okay, so here we need a little bit simplifications, and now we move this 5 inside the term, and it will be written as 2 to the power of 5, and its whole power is 1 divided by log of base 3 and 6 is equals to a. So further in the next step, when we remove this fraction, so it means that here first we write this 2 to the power of 5 is equals to 32, and its exponent is 1 over log 3 to the power of 6. So if when we remove this fraction, then these two terms are interchanged. Okay, so we write it as this is log of 3 with base 6 is equals to a. So this is the final value of a which we get here in this method. And further in the next step, we need to verify that is this value of a is satisfied our given question statement or not. So for this we need to copy down given question statement here. So the given question statement is log of the base 2a and plus log of a with base 3 is equals to 5, and here we substitute this value of a on both of these terms. Okay, when we put this value here, it will be written as so this will becomes log of base 2, and we have the value is 32 to the power of log 3 with base 6, and plus in the same pattern we put the value of a here, it is log 3, and the value of a is 32 to the power of log of 3 with base 6, and here we check that is this equals to 5 or not. And in the next step, here we use the nice property of log, and you know about that. If we have log of a to the power of m is equals to m times of log a. So according to this property of log, we move this exponent in the front of this log, and it will be written as log of 3 with base 6 is multiplied by log of 32 with base 2, plus in the same pattern we again move this exponent in the front of this log, and it will be written as log of 6 with base log of 3 with base 6, and we get here log of 3 into 32, and we check that is this equals to 5 or not. So here we know about that. Here we first we write this 32 as 2 to the power of 5, and it will be written as log of 3 with base 6 multiplied by this will be written as log of base 2, and this will becomes here 2 to the power of 5, plus in the same pattern we write these terms as log of 6 and 3. So here we write this term as log of 3, and we write this 32 as 2 to the power of 5, and we check that is this equals to 5 or not. So here we back use the formula, and here we write these two terms as in this form. This will becomes here log of 3 divided by log of 6 multiplied by, here we move this 5 to the front of this log, and it will becomes here 5 times of log 2 divided by log of 2, and plus from here we have log of this will be written as log of 3 divided by log of 6, and again we move this 5 in the front of this log, and it will become here 5 times of log 2 divided by log of 3, and we check that is this equals to 5 or not. And here we need a little bit simplifications, and you see here this log 2 and log 2 are cancelled out by each other. From here this log 3 and this log 3 are also cancelled out by each other, and we get here so from here you see that this 5 is present on both of these terms, so that we will take common 5, and we get these to be the same, we get these two terms, so we write it as log of 3 divided by log of 6, plus from here we get log of 2 divided by log of 6, and this is equals to 5 or not. So here further in the next step we need to take the LCM of this term, and when we take the LCM it will be written as log of 6 with the LCM, and we get here log of 3 plus log of 2, and we check that is this equals to 5 or not. And here when we combine these two logs by applying the property of log, so you get here this will be written as log of 6 divided by log of 6, because when you combine these two logs, so we multiply 3 times 2, and 3 times 2 becomes here 6, and we check that is this equals to 5 or not. So this log 6 is cancelled out by this log 6, and we will get here 5 is equals to 5. So this shows that the value of a which we get here is satisfied our given question statement. So this is our final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.